Hi, we are Team 6, and we are presenting TuneTuna, our data product that predicts the next musical hit. The objective function of this product is to predict whether a song will be a hit or not based off of its characteristics. The customers that would use this product would be music record label companies and producers, and this would help them scout their next music product. They could quickly scout potential hits to over millions of products and songs, and then they can produce music clips on platforms such as TikTok. So our hypothesis is by assessing these characteristics in new songs, we can inform a record label's decision whether to sign a particular artist or to produce music similar to the certain acoustic profile. Our data came from a Kaggle data set that was pulled from Spotify's web API. Each track was assigned a 1 or 0, which was a binary code for hit or flop. And this was based off of their commercial success, which basically said if it is a hit featured on the Billboard Hot 100 at least once. And so we downloaded 5 decades of data, and we combined them together as one for our main data set. Each track was ranked with different characteristics such as danceability, energy, and duration and tempo. And these were numerical rankings that were put together by Spotify's acoustic profile API.
So we have used logistic regression, random forest, and clustering as our models for analysis. For logistic regression, we used it to predict a song, if a song is a hit or not, through capturing the correlations of the song features. We trained the model using 90% of the song data from 1960s to 2010 and tested using 10% of the data, which is approximately 4,000 data points. And we included most of the independent variables from the song features, except for the track and artist names and the duration. Based on the result from the logistic regression, by looking at the coefficient and p-value, we identified that all the p-values for the independent variables are significant, and we identified that some of the features such as loudness, danceability, and instrumentalness are more positively and negatively correlated to the model as compared to some of the other features. We evaluated the performance of the regression model by looking at the confusion matrix, and we see that there's consistent performance of the model by looking at the accuracy, precision, recall, and F scores, which are all approximately 74 to 75%. Then we took a look at the ROC curve and the AUC measurement, and based on the cutoff point of 50% probability, we see that there's 80.97% chance that the model is able to distinguish songs between a hit and a flop.
Great. And the next step that we took was to take a look at decision trees and random forests to predict. And we ran our data through a random forest, which was made up of 300 decision trees. And we did the training using 89% of the songs from our overall data set and tested using the 10%. Again, the same kind of features were analyzed. We did not actually exclude any feature. And we found out that there were certain variables that explain a lot of the distribution of the data that we had. Variables like instrumentalness, acousticness, and danceability, again, were very important, which kind of is similar to the results we found from logistic regression. Of course, with random forests, we do not get an insight into what the impact, whether positive or negative, but we do get their relative importance. And so just to do a quick comparison between the performance of logistic as well as random forest models, we see that the accuracy has improved quite a bit. The random forest is working at almost 81% accuracy. And also the rate of false positives, a song being characterized as a hit while it was a flop, has also reduced. So we've gone from around 696 false positives to around 472, which is certainly an improvement. And also looking at their ROC curves and the area under curve, we see that there is an improvement here as well. The random forest has an area under curve of around 0.89, which is better than the 0.8 that we had with logistic regression. And so we decided to go with the random forest as our predictive model for our prototype. And yeah, just as a summary, I think both of the models are reasonable for predicting at around, that 75–80% accuracy mark. However, we think that there are certain things we can do to improve their accuracy, which we'll talk about towards the end of our presentation as well.
So apart from predicting the next big hit, we also want the music label companies to know what kind of music are now very popular. And by this, they will have a better idea of which kind of songs to produce. So what we used was clustering analysis. So the objective was to tell the companies what are the most common genres of the great hits. So we took 4 steps. The first one was to calculate the z-scores for all the features for all the songs. And then we selected the data of the hit songs with their z-scores to create a separate data set. With this data set, we use clustering analysis with 5 clusters, and we analyze the features of each clusters to see what are the most salient characteristics that they have, and we interpreted these characteristics to categorize them into understandable genres. So here we can see that 46% of all the hit songs are danceable, electronic, loud, energetic, positive sounding. The rank is by their salience among all the other data sets, among all the other data. And we can categorize them into the dance music. We can see also that 24% have the characteristics as the letters shown in blue color, and we categorize them into country music. And this is followed by rock music, EDM music, and also the romance ballad music. We can say that these are the most common genres of the great hits.
Next up, we'll take a quick look at our prototype that we built for TuneTuna. And for the purposes of the prototype, the songs that we are showcasing as potential new songs that record labels would be evaluating whether to invest in or not are essentially existing songs. We just wanted to call that out because this model requires an input as the acoustic profile of the song. And while we have acoustic profiles available for all the songs on Spotify, it is a proprietary algorithm that Spotify owns. So any new song which is not on Spotify, we won't be able to get those acoustic profiles. And so that is a precursor. But I think our customers, the record labels, as well as potential new investors like Spotify themselves, can use that algorithm to generate the acoustic profile and then use our model for predicting success. So quickly jumping into the demo. So here we have TuneTuna and essentially a list of songs that you can select from and just click predict. So I'll just select 3, click predict, and it essentially calls an API that has exposed the random forest classifier. And it gives us a probability score of whether it would be a hit or not. So for example, this first song, Pelican from Samples, has an 11.33% chance of being a success, and so categorized as a flop. The threshold value we are using is 50%. Counting Crows, definitely a hit, I agree. And wow, our model does not like this song at all. This is just a quick demo of what our model looks like. And finally, in terms of the next steps, I think we can improve our predictive model by dividing our overall data into smaller data sets, slicing them based on the era, the decade that they were launched in, as well as the genres, the different clusters that they belong to. I think that will help us uncover more correlations that exist within genres, as averaging them out over the whole data set across like 50 years would kind of reduce the predictive power. And also we think one thing that is missing is the potential for a big name artist to contribute towards the success of a track, because we have not considered artists as a predictive variable at all in our model so far. So we would also want to find a way of using that as well to be a contributor and a predictor moving forward. And that's it. Thank you for your time.